This is a quick update video about my 4-bit binary adder-subtractor that I built out of NEX. And I wanted to make this before I probably disassemble this thing so I can use the parts for other big projects like this. So what I've changed is mostly down here at the bottom. In fact, I totally rebuilt the bottom 2 or 3 layers of this whole thing. In fact, had to be raised up by a layer or two because it just needed the space down here for all the stuff I added. So what I've done is, well, if you recall from the first main video, there used to be 5 little slots out here for the 5-bit number, which is the answer or the thing this actually calculates. And it was either ball for a 1 or a no ball for a 0. But now we have these 5 dials to represent the 5-bit number. So here you have left for 1 and right for 0, just like up at the top with the input, except this time you're reading it rather than setting the dials yourself for input. So here to test it, I've already set up the balls at the very top, and I've got a quick example. I've got 1 0 0 1, which is 9, plus 1 0 0 0, which is 8. So we should be doing 9 plus 8. And I'm going to zoom down to the output so we can watch these dials turn. There goes that one. And the last ones, there we go. So at the bottom we got 1 0 0 0 1, which is 17, which is 9 plus 8 in binary, just as expected. And so the motivation for doing this was, well, it has a couple of benefits. It's kind of more modular and more reusable this way, because now all the balls come out in this one place, this one ramp right here at the back. And so, instead of coming out some at the front, some at the side. So like you could, in theory, make a chain lift to bring the balls back up to the top and reload the machine automatically. That's something I thought about doing, but decided not to bother because this thing is tall enough. And I think I'm not even sure I would have enough room in this with the ceiling space to make that happen. But it's more reusable in that way. But also, you wouldn't even need to have this common area for the balls. You could have just the outputs continue down into some other device. Imagine that this is like the part of the ALU of some larger, massive NEX computer. And the gears here just help you peek at the output, but you could have those same 5 bits go down into the input of another, memory device or some other thing that needs those values. And this is just a way to do that, in a more modular way. You can peek at the output, but you don't actually affect the balls at all. So it has a couple benefits like that, at least in theory. Of course, I don't have the space or the connects to make those kind of things, but it would be really cool. So what I had to do to the rest of the machine to make sure it worked with this new style of output was primarily update or reroute all of the outputs to each of the 4 full adders that this whole build is made of. So it was mostly the bottom half of the machine that I had to update, the output part, whereas the input part, the upper half, pretty much stayed exactly the same. And so internally here, there are some very important but very subtle changes to reroute all of the outputs of each of the full adders. And if you look at my little full adder chart right over here, each one of these squares, except for the crossed out ones, is a area of the full adder where a ball can come out of. It's an output to the full adder. And before I did this update, all of the things that have a 0 or a D in them really didn't matter. Those were all just discarded because it was only the ones, specifically the S ones, that actually came out to the front and were the balls you saw as the output. But now you need to worry about the zeros because they set these dials one way or the other, depending on whether a ball falls on this side or the back side of those little ramps you see. And also, you need to make sure that the discards don't get in the way of the zeros, because before, all of the zeros and discards just kind of went down that column right about there. But now we actually need that space for all of the 10 channels, two values, 1 and 0 for each of the 5 bits, there's 10 kind of areas where the ball can fall, and you want to make sure the discard doesn't get in the way of any of those. So that's what this whole new pathway back here is for, to just catch the discards and get them out of the way, though they do end up in the same place in the end. And it's kind of a quirky bit about the full adders that they take in 3 inputs, but only 2 of the outputs are really useful. So you just have this kind of odd discard ball that you don't need, because you only need the sum and the carry of the full adder, and you got to put that other ball somewhere. So that's what that's for. And yeah, that's pretty much it about what I've done here. I did stream most of the changes I made and most of myself updating this, so you can check the links in the description to see the VODs of that if you're really interested. But I'll end here with just one quick more demonstration of 4 plus 12. I've got that primed up at the top, and I'll try to show some of the discard paths, and then go back around to the input. There's a discard ball already happening. And there's another one, and you can see the other balls going down in the center and setting the dials. So there we go. We did 4 plus 12, which is 1, 0, 0, 0, 0, or 16, and the machine still works as expected.